to Clarksville Academy's Science STEM Lab and Makerspace. We conduct weekly science experiments for lower school, kindergarten through 4th, in this room. We also have a collaborative space that any grade level, pre-K through 12th, can come with the makerspace philosophy and hands-on collaborative work, connecting, working with teams or individual. We also operate our robotics team, which is intermediate school within the confines of this room. So this room affords us a great deal of space and supplies to connect with our students in a hands-on, engaging way. For the practical purposes of this conference, we're going to discuss how we use this particular space for our creative project that we call Code-A-Palooza. It is a computer science-based event that we host using our entire school, pre-K through 12th grade. Our event, which we call Code-A-Palooza, is a week in December. I'll have a student explain why. A week in December that we utilize the time frame that they're with Science Lab for computer science education. Our goal is to achieve equity among all grade levels with an experience in coding. We start out with our youngest students in pre-K, and we work all the way up to our high school students. As we introduce this Code-A-Palooza topic to you, we're going to enlist the help of a few well-known robots. As you can see from the map behind me, our Code-A-Palooza event is timed with the International Hour of Code, and we participate in that regionally, but our students get to experience what it's like to be part of an international focus on educating students, from our youngest students in pre-K, which start with very simple coding, up to our high school students who are creating their own games. We love to encourage the teamwork of high school students helping our elementary level students, and we love when our school can participate in an event that includes all 500 plus students. During our Computer Science Education Week, we do a lot of discussing about robots, and as you can see behind me, we enlist the help of some very famous robots. We play and learn coding on some very inexpensive JIMU robots. Our kindergarten through 4th grade enjoy watching these perform specific code. They also design a robot in 1st grade on paper, blueprints, and the robot has to perform a function that helps our Earth, whether it's recycling trash or whether it's cleaning air in rooms, as many of them have learned the conditions in our classrooms during this particular time. We wanted to increase our air purification, so many of them designed robots that did that. Our 3rd graders do a dance-off party and code robots on our Apple TVs to perform dances, and then they mimic them. Our 4th graders learn how to write their name in binary code. So we have a progressive curriculum enhancement that moves the kindergartner up through the 4th grader in a level of building on coding. Then our middle schoolers code Spike Prime robots to perform functions, and our high schoolers work in their computer science classes doing coding at a much higher level.
Grace Hopper was an American computer scientist. She was a United States Navy admiral. She was one of the first programmers. She was a pioneer of computer programming. Grace Hopper invented one of the first linkers. She enjoyed taking things apart. When she was 7 years old, she dismantled 7 alarm clocks to see how they worked. Grace Hopper loved math. We celebrate Computer Science Week in December because she was born on December 9, 1906.
Our Computer Science Education Week is always hosted in December to correlate with Admiral Grace Hopper's birthday. Grace Hopper was a pioneer in the computer science field, and our students know her name because of the character Hopper from Swift Playgrounds. They are very familiar with the Swift Playground system and enjoy celebrating Hopper and Grace Hopper's birthday during our Computer Science Week. We do a lot of different activities, and you will have access to all of the things that I've mentioned. The papers I will have uploaded. You will have access to the videos that you can see how we construct models of robots using toilet paper tubes. Our students love hands-on engagement, so you'll have access to that information as well. Please feel free to contact me at my email address, which will be provided, and you yourself can establish a week of computer coding at your school that also correlates with Grace Hopper's birthday and Computer Science Education Week that falls early in December. To help link our hands-on creativity with our Computer Science Education Week, incorporating the use of technology and coding, we like to have each grade level participate in some hands-on creativity activities. Our kindergartners love to color robots. Our first graders design and make a blueprint of a robot that performs a certain function to help our Earth. Our second graders create, and you will see in an upcoming video, a robot using toilet paper tubes and craft items. Our third graders, we get up and dance. You'll see that in one of the upcoming videos. And our fourth graders learn to create their name and binary code. We feel that connecting the gears of creativity, discovery, and learning with hands-on, connecting that gear with the technological gears of coding and using iPads and robots, help a student experience a full spectrum of activities and learning throughout our Computer Science Week. Here are the robots that we use during our Computer Science Education Week. They have an increased level of performing, so our kindergartners love using the unicorn robot. Our kindergarten and first grade love using the MeBots. The next JIMU robots is the Cosmos kit, and those can be designed in different formats. And then our middle schoolers code with Spike Prime robots using scratch coding. The others are a downloadable app that we have 4 iPads that remain in the classroom, and so the students use those 4 iPads when they come in for their hour of code, and they enjoy using these to perform the functions that are pre-coded in the robot kits. Kindergartners and first graders enjoy Computer Science Week and are entertained when we get out the Ozobots. I simply drew a black line as their highway, and the Ozobots will follow the black line. In fact, they will follow any black line that's thick enough, and so many of our students enjoy watching the Ozobots follow their name when they write it. So they write their name, and as long as the black line is thick enough, the Ozobot will follow, and the students enjoy that tremendously in kindergarten and first grade. It works on their fine motor skills, as well as helping them understand that these robots are coded to perform certain functions. They are also perform certain functions when they reach a color. You can do the color with any marker. This color is coded as light show. So when the robot gets to blue, green, blue, it turns on the light show. when the robot gets to this color code, it will stop and turn around. So the students enjoy this particular element of the Computer Science Week, featuring Ozobots. To explain what coding is to our youngest students, we use a familiar text, The Three Little Pigs. The students have to place the text in order or sequence it so that the result is the end of the book. We teach them that coding starts at a certain point, progresses, sometimes has something we called a loop, which means that they do the same thing over and over. So we introduce the example of loop by I'll huff and I'll puff and I'll blow your house down. We introduce that 3 loops equal the story. The pigs purchase something, build a house, and the wolf huffs and puffs and blows it down. Sequence 1. The loop happens again. The pig purchases something, builds a house, and the wolf huffs and puffs and blows the house down. Loop number 3. The pigs purchase something, build a house, and the wolf huffs and puffs. This time the sequence follows by the frustration of the wolf and the fact that the house does not come down. Then we have a conclusion to the story where the code stops. So we print off simple pictures from a book that is very familiar, and our students understand that putting in order what we want to happen from beginning to end is the same thing that happens when we code a robot.
Woo!